Okay, this is section 1.2 of Algebra. A power has two parts, a base and an exponent. If we look down at this picture here, the base is the 2 and the exponent is a 3. The exponent tells you how many times to use the base as a factor. We would read this power as 2 to the third power, or 2 cubed. When we simplify a numerical expression, we replace it with a single numerical value. So if we had 2 times 8, to simplify that, we would multiply it out and get 16. Okay, so here we have 10 to the 7th power, which is 10 times 10 times 10 times 10 times 10 times 10 times 10, which is 10 million. So we simplify 10 to the 7th to become 10 million. 0.2 to the 5th is equal to 0.2 times 0.2 times 0.2 times 0.2 times 0.2, which gives us 0.00032. Okay, if we look at our got it questions, part A, we have 3 to the 4th, which is equal to 3 times 3 times 3 times 3, which when we simplify it is 81. In part B, we have 2/3 to the 3rd power, or 2/3 cubed. This is the same thing as 2/3 times 2/3 times 2/3, which is about 0.296. And in part C, we have 0.5 to the 3rd power, which is equal to 0.5 times 0.5 times 0.5, which is equal to 0.125. When we have multiple operations in one expression, we need to have an order of how to do things, which is where the order of operations comes into handy. PEMDAS, or PEMDAS, which I memorized by knowing "please excuse my dear Aunt Sally," tells us our order of operations. We start with parentheses, then exponents, then we use multiplication and division, and addition and subtraction. If we have multiplication and division in the same expression, we work from left to right, and the same goes for addition and subtraction. We would work from left to right. Okay, in part A, we have parentheses, so we need to start with our parentheses. So we have 6 minus 2, which becomes 4. So now our expression is 4 to the 3rd power divided by 2. So since we have exponents next, we simplify 4 to the 3rd power, which becomes 64. And now the only operation we have left is division. And 64 divided by 2 gives us 32. In part B, we have a fraction bar, which we treat as a grouping symbol. So we're going to simplify the top on its own, and we would simplify the bottom on its own if it needed. And then our last step will be to divide. So if we're looking at the top, we have 2 to the 4th minus 1. Since we have exponents, we'll do that first. So 2 to the 4th becomes 16. And then 16 minus 1 gives us 15. So now our fraction is 15 over 5, which becomes 3 when we divide. Okay, now for our got it question. Part A, we have 5 times 7 minus 4 squared divided by 2. I don't have a grouping symbol, but I do have exponents, so I need to simplify that 4 squared. So I leave my 5 times 7. That 4 squared becomes 16, and keep my divided by 2. Now I have multiplication and division in my expression, and I'm going to start from the left and go right. So first I'll do the 5 times 7, which gives me 35. Just leave my subtraction sign, and I'll do 16 divided by 2, which gives me 8. Now I only have division left, and when I I only have subtraction left, and when I do 35 minus 8, I get 27. So our answer is 27. I'm going to erase this so I have room for part B. Okay, in part B, I have 12 minus 25 divided by 5. So I don't have any parentheses, I don't have any exponents, I don't have any multiplication, but I do have division. So I'll start with my division. So 25 divided by 5 gives me 5. Now the only thing I have left is subtraction, and 12 minus 5 gives me 7. Part C has a fraction bar. So like I said before, we're going to treat the top as a group and treat the bottom as a group. So if I start by looking at the top, I have 4 plus 3 to the 4th. So I'm going to simplify my exponents first. So I'll leave my 4 plus alone, and 3 to the 4th gives me 81. And then I have addition left, so I just add those and I get 85. If I then go back and look at my bottom, I have 7 minus 2, which is 5. I'll carry my 5 over to this fraction. And now I can divide. 85 divided by 5 is 17. Part D says, how does a fraction bar act as a grouping symbol? Well, when we're using a fraction bar, what we're really doing is division. So if I had the fraction 3 plus 5 over 2 minus 1, what I'm really doing is I'm doing 3 plus 5 divided by 2 minus 1. And do you see how I needed to add parentheses for that to work out? So that's why a fraction bar acts as a grouping symbol. And when we use the fraction bar, that'll always be the last thing we do is divide. Okay, when we evaluate an algebraic expression, remember that an algebraic expression is one that has variables in it. So a letter like x or y, where numerical expressions only have numbers and operations. So when I evaluate an algebraic expression, I replace each of the variables with a number. So if I'm told that x equals 2, then I can plug in 2 for any x in my expression. So if we look at part A here, I'm told that x is equal to 5 and y is equal to 2. So my algebraic expression is x squared plus x minus 12 divided by y squared. The first thing I do is plug in the 5 and the 2 for x and y. So it turns into 5 squared plus 5 minus 12 divided by 2 squared. And from there I use order of operations. So since I have an exponent, I simplify that 2 squared to become 4. And then I have division, so I do my 12 divided by 4, which gives me 3. And I have addition and subtraction left, and so I work from left to right. So I do 25 plus 5, which gives me 30, and then I subtract the 3, which gives me 27. Part B, I have x times y to the second power divided by x times y. So I plug in x equals 5 and y equals 2. So this turns into 5 times 2 to the second power divided by 5 times 2. So since I have parentheses, I need to take care of that first. So I multiply 5 times 2 and get 10. And then again I multiply 5 times 2, which gives me 10. Since I have an exponent, I need to simplify that. So I simplify 10 squared to become 100. And then the only thing I have left is my division. So I do 100 divided by 10, which gives me 10. If we look at our got it questions, I'm told that A is equal to 3 and B is equal to 4. So I'm going to plug in 3 for my A's and 4 for my B's. So part A, I have 3B minus A squared. So B, I'm told, is 4. And A is 3. Now, do you see how I use parentheses here? I use parentheses as multiplication. I could have also written as 3 times 4 minus 3 squared. I wouldn't treat that as parentheses because all I'm doing there is multiplying. But if we look at it like this, I have an exponent, so I need to simplify that. So I have 3 times 4 still. and my 3 squared becomes 9. And then I need to simplify my multiplication, so 3 times 4 becomes 12 minus 9, which becomes 3. Now if we look at part B, I'm still plugging in 4 for B and 3 for A. So I have 2 times 4 squared minus 7 times 3. I have an exponent, so I'll simplify that first. 4 squared is 16. Now I have 2 multiplications going on here. I'm going to start on the left side. So 2 times 16 gives me 32. And 7 times 3 gives me 21. And now if I do my subtraction, 32 minus 21 gives me 11. Okay, now here's a word problem. They want to know what is an expression for the spending money you have left after depositing 2/5 of your wages in savings. And they want us to evaluate the expression for weekly wages of $40, $50, $75, and $100. Okay, so we know that we're going to be saving 2/5 of our wages. And we're going to have different wages for different weeks. So we need to have an expression for our spending money. And we need the amount of money, spending money for various weekly wages. So we're going to start by making an algebraic expression. So it's going to have a variable in it. And then we'll evaluate it for each of the amounts that they gave us. So we're going to take however much we got paid, and then we're going to subtract 2/5 of that. So if we let W equal our wages, how much we get paid, our expression is W minus 2/5 times W. So as you can see in this table, if we make $40, we have a total spending money of $24. So we did 40 minus, and then we needed to do the 2/5 times 40. If we're calculating this out on our calculator, we need to use order of operations, and we need to start with the 2/5 times 40, and then subtract that from 40. If we look at our got it problem, it's a similar idea. It says the shipping cost for an order at an online store is 1/10 the cost of the item you order. What is an expression for the total cost of a given order? Okay, so I'm going to take however much my order is, and I need to add 1/10 of that to have my total. So if I call my cost C, I need to add 1/10 of that. So 1/10 times C to get my total cost. Now if I make a table like the one they have there, I think I'm going to need to make that a little bigger. So I'm going to have $43, and if I plug that into my expression, that's 43 plus 1/10 times 43. So I'll do the 1/10 times 43 first, and then I'll add the 43, and I get 47.3. And then if I do my 79, I get 79 plus 1/10, 1/10 times 79. So 1/10 times 79 is 7.9, plus 79 gives me 86.9. And since I'm running out of room, if I plug in 95, I get a total cost of 104.5. Oops. Since I ran out of room on my table, if I plug in 103, I get 113.3. Okay, our lesson check. What is the simplified form of each expression? 5 squared is equal to 25. That's the same thing as 5 to the second power. 5 squared and 5 to the second power mean the same thing. Number 2 is 2 to the third, which is the same thing as 2 times 2 times 2. which gives me 8. And 3/4 squared is the same thing as 3/4 times 3/4, which is equal to 0.5625. I'm just plugging those into my calculator. Okay, if I evaluate each expression, that's when I need to plug in a number for my letters, for my variables. So I'm told that x equals 3 and y equals 4. So if I plug into this first one, I get 3 squared plus 2 times 3 plus 4. I have parentheses, so I need to do that first. So I'm going to leave my 3 squared alone and my plus and my 2 alone. And 3 plus 4 is 7. So this turns into times 7. Now I have an exponent, so 3 squared is 9. I need to do multiplication next, so I have 9 plus 14. And then I just have addition left, and 9 plus 14 is 23. So my answer is 23. I'm going to move 5 down here. So 5 is x times y to the 3rd power, also known as x times y cubed. So if I plug in 3 for my x and 4 for my y, I need to do parentheses first. So 3 times 4 is 12. And then I just have 12 to the 3rd, which is equal to 1,728. And I'll move problem 6 over here. So I have 4x squared minus 3xy. And again, 3 is going in for my x and 4 is going in for my y. So this becomes 4 times 3 squared minus 3 times 3 times 4. So I need to evaluate my expression, or sorry, excuse me, my exponent first. So this becomes 4 times 9 minus 3 times 3 times 4. Next I have multiplication, and I'll work left to right. So 4 times 9 is 36. Keep my subtraction sign. And 3 times 3 is 9. Times 4 is 36. And 36 minus 36 is equal to 0. In number 7, my exponent is 3, and my base is the 4. Remember, your base is the big number, and your exponent is the little number up top. And finally, if we look at this student's work and try to evaluate it, they didn't get the right answer. If we look at the expression over here on the left, we have 23 minus 8 times 2 plus 3 squared. So we look over to the first step and we can see that they did their exponent first, so they changed 3 squared into a 9, which is correct. But if we look at that expression, our next thing should be the multiplication. But it looks like they did the subtraction first. They did 23 minus 8 first, which gave them that 15. When what they really should have done was the 8 times 2 to give us 16. So if we keep going with it correctly, it should have been 23 minus 16 plus 9, and then we have subtraction and addition, and we need to work left to right. So 23 minus 16 gives us 7. 7 plus 9 gives us 16. Our answer should have been 16. And here's your homework.